Hi, welcome back. This is going to be an interesting video to understand the Arduino Uno board in detail. A deep understanding about the board will help us move to practical projects quickly. The Arduino Uno is considered as the best board by many to get started with electronics and coding. According to the Uno website, the Uno is the most used and documented board at the whole Arduino family. These boards are equipped with the well-known Atmega 328P and the Atmega 16U2 processor. There are two types of Uno boards, SMD and non-SMD. Primary difference is that in the Uno SMD surface mounted device, the microprocessor chip Atmega 328 is integrated and soldered onto the board, while in the standard Uno, the Atmega 328 is DIP, that is dual inline packaged. So this is the top view of the board. This is the 2.1 into 5.5 millimeter power jack. This is the USB-B connector. These boards are a bit dated. Probably that might be the reason for the USB-B type connector instead of type C. Anyways, I will make a detailed video on various types of USB connectors in the future. These boards are the PC1 and PC2. These are two EEE 1EA 470WP 25 volt SMD capacitors. Remember what I said? SMD means surface mounted device. What is the use of these capacitors? So a capacitor on an Arduino board serves several important roles depending on its placement and purpose. When a power supply, like a battery or USB, delivers electricity, it can sometimes have noise or irregularities. Capacitors act as filters, providing a stable voltage by absorbing and releasing charge when necessary. Capacitors are often placed near power pins, VCC and ground, of sensitive components like the microcontroller and sensors. This helps prevent voltage spikes or drops that could disrupt the operation of the board. The capacitor essentially decouples the power source from the component, ensuring stable operation. When an Arduino interacts with external components, especially motors, LEDs or sensors, sudden current changes can cause voltage drops. A capacitor stores and releases charge to maintain stable voltage levels. In certain circuits, capacitors help define the time constant of an RC, that is resistor capacitor circuit, influencing timing, delays or filtering actions in analog signals. So basically, capacitors on an Arduino help ensure stable operation, reduce noise and improve signal integrity. This here is the CGRA4007G rectifier. What is the purpose of the rectifier? The rectifier on the Arduino Uno R3 board primarily serves the purpose of converting alternating current to direct current, which is required for the board's operation. So how it works is, the Arduino Uno can be powered through the barrel jack or the VIN pin. This is the barrel jack and the VIN pin is here. These external power sources are often alternate current. When the external power supply is connected and provides AC, the rectifier, usually made from diodes, is responsible for converting this AC voltage into direct current. This is done by allowing only the positive half of the AC waveform to pass through, thus converting AC to a unidirectional flow. The JZU4 module in the diagram is the Atmega 328P module. As we have already touched upon this multiple times, this is the main processor of the Arduino board. Atmega 328P processor consists of an 8-bit AVR CPU at up to 16 MHz, a 32 KB flash memory, a 2 KB SRAM and 1 KB EEPROM. A flash memory is a type of non-volatile storage meaning it retains data even when power is turned off. It's commonly used in devices like USB drives, SSDs, and memory cards. It stores data in blocks and is electrically erasable, allowing for fast read-write operations. Flash memory is widely used because it's durable, compact, and relatively inexpensive. EEPROM, that is electrically erasable programmable read-only memory, is a type of non-volatile memory that can be electrically erased and reprogrammed. Unlike flash memory, EEPROM allows for byte-level erasure and reprogramming, making it useful for applications where small amounts of data need to be updated or modified. It's often used in devices like BIOS chips, microcontrollers, and RFID tags. SRAM, that is static random access memory, is a type of volatile memory, meaning it loses its data when power is lost. Unlike DRAM, that is dynamic RAM, SRAM doesn't need to be refreshed, making it faster but more expensive. It's typically used in applications requiring high-speed data access, such as CPU caches. It stores data using flip-flops and offers low latency. Now let's look at the Y1 ECS component in the diagram. That is the 160/20 4xDU oscillator. The Arduino Uno uses an Atmega 328P microcontroller, which requires an external clock to operate. The oscillator is responsible for generating this clock signal, which determines the timing for the microcontroller's operations, like executing instructions, timing functions, and communication. The oscillator typically runs at 16 MHz, meaning it generates 16 million clock pulses per second. This clock speed is crucial for the proper functioning of the microcontroller and ensuring that the processing speed and timing of operations are accurate. The oscillator provides a high stable frequency, which is essential for tasks that require accurate timing, such as serial communication, that is UART, and generating PWM signals or time-based events in your Arduino programs. A crystal oscillator like the 160/20 4xDU is chosen for its ability to maintain a consistent frequency over a range of operating conditions. Example, temperature variations, power supply fluctuations. This ensures that the Arduino board operates reliably under the different conditions. Now let's look at the U1 component in the diagram, which is the regulator. This is the regulator. The regulator ensures that all components of the Arduino Uno R3, including the microcontroller and any attached peripherals, receive stable 5 volts power. This is crucial because voltage fluctuations or instability can cause erratic behavior. The regulator allows the Arduino Uno to work with various power sources, example 7 to 12 volts from a battery or adapter, providing flexibility in powering the board while ensuring stable 5 volt output. Coming to the U3 component in the diagram, which is the Atmega 16U2 module. The Atmega 16U2 acts as a bridge between the USB port on your computer and the main Atmega 328P microcontroller on the Arduino Uno. When you connect the Arduino Uno to your computer via USB, the Atmega 16U2 converts the USB signal to serial UART signals that the Atmega 328P can understand. This allows you to upload sketches, those are programs, from your computer to Arduino board and enables serial communication between the Arduino and the computer for debugging, sending data, etc. The U5 component in the diagram is the LMV358 LIST A.9 IC. This is the IC. This is a dual operational amplifier used for analog signal processing. It allows the Arduino to handle tasks like amplifying weak analog signals, comparing voltages, filtering noise, and buffering sensor signals. This IC expands the functionality of the Arduino Uno R3, making it more capable of handling various analog sensors and applications. The F1 component in the diagram is a high density chip capacitor. This is also another capacitor. We have already discussed about the functionality of capacitors in detail. You can see the ICSP and ICSP1 components in the diagram, which are the pin header connectors. The ICSP pins allow you to upload code directly to the Atmega 328P microcontroller using an external programmer. This is useful when you want to bypass the bootloader or when the bootloader is corrupted. These pins can be used to update the firmware of the microcontroller, allowing for changes or improvements to the software that runs on the chip. That's it for today. In the next video, we will understand the pin configuration of Arduino board. Till then, see you all.